What you see here is my Calimero frame. This is a toothpick size 3D printable frame, so 65 millimeter or 2.5 inch props, and it's designed to fit 16 by 16 stacks and these whoop style boards. And a while ago I released a 2-inch version of this, and to be honest I never got around actually building one of those. So this is what I want to do now in this video, and this here is a print made out of PETG and this is PLA here. So both work pretty well. The PLA is a bit stiffer and you have to heat treat it or temper it. So what I do after printing it, I simply leave this on the hotbed for around half an hour, 40 minutes at 85 degrees Celsius. This release tension in the material and ensures that some kind of, as far as I know, some kind of crystallization progress happens in here. I'm not too sure about what exactly happens, but what is clear that it gets kind of soft and that all the tension that is inside the material from printing, because you are applying hot material on colder layers, this will create tension. So this is supposed to relieve the tension. It makes the material much stronger and much less brittle. So this is what I will be building now, and I have my little TPU pod here. This is the lighter version of it. This one is around 1.4 grams, so much lighter than the previous one. And I'm looking forward to try out the 2-inch size. I'm not quite sure how it will perform compared to the toothpick size, but I see in any case I leave the motor wires a bit longer, so I have the option to transfer this back to toothpick size if I don't like the 2-inch props. Another thing I tried, because this frame is quite small and really stiff, I thought I could give it a shot to build one out of TPU, because TPU is basically indestructible, so it would be really cool to have a frame made out of it. But my attempt here just resulted in something that is way too soft. I mean, I kind of expected it, but I gave it a try nevertheless, because it just had to give it a shot. This is so soft that I don't see any scenario in which a flight controller would be able to deal with this. So unfortunately, I'm not going to try this. I'll go with the PLA version. Alright, let's take a closer look at the components I'm going to use. These are Brother Hobby 1103 11,000 kV motors, which should be fine for the 2-inch on 2S. Now, while I think these look great and the quality seems to be really good, I had a little bit of a bad surprise, because Brother Hobby started making these with 3-hole motor mounts and then switched to 4-hole, and you can already see what my little dilemma is here. I got 3 4-hole versions and this 3-hole version here. So for the Calimero it doesn't matter too much because it fits both, but it's a pity that this still happens. Another the disappointment, and this one I wanted to use connectors, and this motor has got connectors. You also get the little counterpart here, but unfortunately this isn't the same connector type we have on our standard 12 amp whoop boards we all use. This is much bigger. This doesn't fit. Also the little counterpart thingy here is too big. It's way bigger than what we have on here. It just doesn't fit. So I'll have to desolder this and solder the motor wires. That's kind of a bummer, but shouldn't be too much of a problem. So the camera I'm going to use is the Runcam Nano 2. This is not the Nano Racer, the more expensive one. This is the cheap, around 15 euros, I think. This is the cheap one, which is, in terms of image quality, somehow much better. So this is what I use most of the time on my builds. Electronics, what I'm going to use here is something that I haven't seen a lot. This is the Aurora RC 12 amp board, and I compared this to the Gap RC board because I thought they look pretty similar, and they are absolutely identical in terms of layout. Of course, this one's got another color. I think it's got a slightly nicer color than the Gap RC or Beta FPV, but the layout is the exact same you would get on the Gap RC board. I am not sure if the components on there are the exact same. There's no way for me to to figure this out. What I noticed that these ones here have little markings here reading stuff, and I didn't have that on my GapRC board, but that doesn't mean they're different. And let's see if they perform. I mean, in terms of price, they are pretty much the same. So I think this should work fine, since most GapRC boards that I had were okay. The VTX I'm using, this is the new Ishin Nano VTX. This is pretty much my standard go-to VTX. It's super cheap. It's like 12 or 13 euros. It does 400 milliwatts and has smart audio. And I tested this with an RF meter. It actually really does 400 milliwatts, at least when it's not overheating. So this is my go-to. Really small, light, good VTX. And the receiver I'll use, this is an RXSR. To be honest, I had some issues with my XM receiver, so XM, not XM Plus. I don't know if I got a bad one, but the last one I used was a disaster, so I had failsafes all of the time and was super annoying. The other ones I had were better, but will play it safe here and use the more expensive but better range RXSR. So personally, I like to mount the motors first, put the board in its place. So if everything is at its final spot in the build, it just makes it much easier for me to have a clean build, but that's just my personal preference. So first thing I did after that is cut the motor wires to be able to direct solder them, all four. I mean, might be nicer ways to do this, to remove them, but I just cut them. Now the next thing is to desolder the connectors, and this can be pretty annoying, but the way I used to do it is just to put this big blob of solder on all three of these pads and then heat all of them up and remove them with some tweezers. See that one of them got stuck, removing that one too. It works quite well like this. Now afterwards I apply some flux to get the excess solder off clean. I have one of those vacuum things to suck off the excess solder, but for me it just works better to kind of scratch it off with the soldering iron. I remove the solder from the soldering iron, get back to it, and it just absorbs the excess solder. So as you can see, the result is kind of nice and clean. They're already pre-soldered for soldering up the motor wires. So this is really the annoying part. They are so close together and it's really hard not to short them, so you have to be super careful and look at them really up close to ensure that you are not frying your ESC. So the next thing I'm connecting here is the VTX. The T1 pad goes to the smart audio on the Ishin Nano. The signal goes to the video out, here the pad that says out, and then connect the 5 volts to. And an interesting thing here is that at least on the Beta FPV board, the ground pad that you see here, the G, does not take more than, if I remember correctly, 0.6 amps, which is very little. So what I always do, because these boards are almost identical, just in case these have the same constraints, I just put it directly to the battery ground to be sure that I don't have problems, especially on this 400 milliwatt VTX. So now next up, this is the receiver ground, 5 volt through the 5 volt pad, and to RC I put my S-bus. Now the last thing to connect is the cam, so signal in, ground. And now the 5 volt gets kind of annoying because none of these boards has a spare 5 volt pad, so I just have to put it on the same as the VTX. And now we're almost done. I'm just putting some shrink wrap around the receiver and the VTX to protect it because I will just put everything inside of the canopy. So as you can see, it's just all stuffed in there, and now we are pretty much done. The last thing I have to do is use a zip tie to secure the antenna. Just Goes around here real easy. Alright. Looks quite cool in my opinion. Really like the red and the black matching the motors. So the props I'm using are these Emax Avon 2-inch props. They are really aggressive, and if you saw the start of this video, the first clip where I simply crashed, this is because they were sucking the batteries dry so quickly that the flight control is shut off. So these are way too aggressive for the 11,000 kV motors, which I found out then when flying this, but still they look pretty cool. Weight with those props comes in at pretty exactly 51 grams, so that's connected and sounds good. So now here comes a kind of disappointing part, because these props on those motors, so the 11,000 kV Brother Hobby on the 2-inch Avon, just don't add up. The props are way too aggressive for this high kV. Even on 2S, this is a 2S 450 milliamp hour battery, they were just killing the battery and just grossly inefficient in training. And I was struggling to get to 1 minute 50 of flight times and above 50% throttle. Pretty much nothing happened, although the flight characteristics were fine up to 50%. So for cruising around like this, it was okay, but nothing in comparison to a Toothpick with 65mm props on a 10,000 kV 1103. So probably what I will do, I mean, I could get some lighter props, but I will probably just print the exact same frame in black PLA in a 65mm version and transfer this back to a regular Toothpick. Of course, this is only my personal hypothesis that these props are too aggressive for the KV. I don't know if you have similar setups or maybe more experience than me with 2-inch builds, because to be honest, I don't have a lot. I was mainly building Toothpicks in the past. Let me know what your take on this is and what you think went wrong here. Just leave a comment below. And yeah, as always guys, thanks for watching. Don't forget to subscribe. Bye bye.